computer science more than anything in the universities, the thing that built the world that we all live in. So it's probably good once in a while to get the view from someone from the outside who looks in. So many things probably will, even the vocabulary will look different to you, but I will try to put CS on a very big platform to view what it does. So I will have one request though. This talk is not a technical talk in which if you don't understand one thing, you cannot understand what follows. There will be tons of questions, and I will be more than glad to come and have a roundtable discussion. But if you can avoid questions holding up to the end, that will be the best. Okay. So I have to explain first what do I mean by clocks and clouds. That's the title of a book that I'm writing. Okay. The clock comes from the clock view that gave us the Enlightenment, the Industrial Revolution, and everything that follows, Newtonian. But the world is now very, very different. And the clocks and clouds comes from Karl Popper, a philosopher of science. A clock problem is one that which you can decompose something, put it back together, and it work. Cloud is more like changeable. Okay? So, but a lot of the ideas that you will see here are based on what was the central point of this book, okay? That was that lots of things thrive at intersections. And the book was about the intersection between the modes of thinking of art, technology, and science, okay? That intersections matter, okay? So I alluded this briefly, but the world that for a while was a nice little world to live in was certainty, determinism, cause and effect. They were related, was controllable. It's a world that we will see later on, gave us even the US Constitution. Okay? The world that we live now is this. This is the world where there is a infrastructure of reality of which you are the ones who built this over the years. Okay? So, but I said I'm going to start by putting CS on a very, very big canvas. And I will start with the thinking modes that underline art, technology, and science, okay? And the concept behind science is to discover how things work, is to reveal the truth, the world as is, technologies to invent, and many people here will equate it with create, okay? So where does CS fit in all of this? Let's start with math. Math is half and half. Mathematicians between the Platonists that think that math is there. It was discovered, and people who think math was invented. And if you apply math, it will be there because it's invented. Computer science, they are parting here, and I will say a little bit more. The whole team problem was not invented. It was there. It was someone discovered it that it was there. Okay, but it covers the whole territory, and I will argue that there's a lot of creation and certainly a lot of invention there. And you can, as an exercise, you can find what words underline other domains. So, for example, talking with people in philosophy here, ask, for example, philosophy will be interpret, question, understand. Okay. Now, before going to CS, I want to dig more deeply into, I mentioned art as a reference point, how change happens in domains and how domains evolve. Okay, those are big things. Art, I mentioned creation. But the truth is, no artist, if you ask them what drives them, will say, I want to create. Create is a byproduct. Any of these words, as many as I could fit in the screen, could be things that drive artists. Reframe, transform, provoke. And you can question yourself, what's the verb that drives you? It's an interesting exercise to do, okay? But I wanted to mention art for one reason. is because it's so multidimensional in this respect. And when I talk about, I'm talking about modern and contemporary art, and not Western art prior to 1900. So the first one is how change happens. Change there are two things that you have to define in here. Domain, field. A domain is a body of work that exists, that even if humans were wiped from Earth, will still be there. Let's say condensed matter physics is a domain. Poetry, and you can divide it in different components, is a domain. The field is the people who practice in the domain. How new ideas get incorporated into a domain is because there are gatekeepers who decide what idea is worth keeping in the domain. Usually they will be that the idea gets presented in a conference or it's a paper. In some fields, the decision is very clear. A theorem is either right or doesn't exist. In other fields, for example, art is the confluence of collectors, critics, museum directors, the artists themselves. There is revision as to what belongs there. Now, I will say that, and here I'm not going to say much, is something, a little teeny things I talked with Aravindan about that you can think of a system that contains a body of knowledge, okay, a way of massaging that knowledge and creating new knowledge, an evaluation function that decides whether or not the things stay there or they are discarded, okay? And the consequence of this is that a system that generates ideas using rules, evaluating them using fixed criteria, can only produce and accept what the rules and criteria. Okay, so it's a nice little teeny thing, mostly logic then, okay? But I want to hammer the idea of ideas created in a domain. So let's say that this is the domain. This is the edge of the domain. This is what people will call the accessible possible. This is where you go to meetings just to see people at that edge. They are all there. Okay, so I'll explain kind of here. So there is a domain there. If there are no ideas, they get in the domain. If the ideas are very big, they may be kind of break through the boundary domain and they will enlarge it. Those I would call a breakthrough. But there are ideas that are so far off that they are outside the domain. I call those breakways. A breakway could be quantum mechanics, classical mechanics. You don't go logically derive quantum mechanics from classical mechanics. In fact, in order to create quantum mechanics, you have to disavow every assumption that underlies classical mechanics. Another one could be you cannot go from representational Western art prior to 1900 and somehow ended up with Cubism. There is also something, I will allude this briefly, you can give a whole little talk about this, on how radical the ideas are. And you can put them in a quadrant in which you put them, the relationship with the existing framework and how the depth of the change. So CS sits in between science, which accumulates knowledge, and technology, which tries to break constantly with things of the past, okay, for competitive advantage. So, for example, examples of breakways. The period 1900, 1925 was chock full with breakways, okay? In physics, you have quantum mechanics, relativity, broke with the past. In arts, abandoned representation. Literature, you have Virginia Woolf, Proust, Joyce, abandoning conventional narratives. Architecture, Stravinsky. In music, all of these were break with that happened in that thing. And in technology, you have a whole bunch of them as well. Things like, for example, technology, photography, when it appeared, a French poet, Baudelaire, declared photography mortal enemy of art. Similar comments to what people make today about AI, okay? And then art evolved, absorb photography, and so on and so forth. And then if you go closer, 2025, you have a whole bunch of things that you could describe with the word or verb prompt. Okay, those represent breaking with, represents a break with. Okay, so but there are three evolutionary logics behind art, technology, and science. Okay, in science, the biggest discovery of science is science itself. It's how it works, and this is what most people don't understand. When science changes something, outside people think that's a failure. No, it's data. That's how science works. Accumulates knowledge periodically. Once in a while, there may be a revolution. Those are very frequent. Quantum mechanics will be one. The discovery of molecular biology, DNA, would be another one. And it keeps moving. There are no kind of use for dead branches in science. Some people keep going in there, but they are not part of the main route. Technology is continual adaptation. You don't wait for one technology to run its course before another one tries to replace it. Okay? So how about modern art? So modern art, probably the best way that I have to explain those curves is in there, or the curves that I'm going to show to depict modern art is this. In here, I'm showing you a whole bunch of paintings between 1910 and 1988. Unless you have taken a course in modern art, if I ask you, put them in chronological order, there is no way on earth that is done. In fact, if I ask you what two were done by the same person, there is also no way that you can do it. And that tries to explain there is no idea of progress in modern contemporary. It's continual reinvention and creating your own new DNA space. For example, that's the oldest. This is the oldest. That's the newest in there. These two done by the same person, Gerhard Richter from Germany, still alive. So that typifies what I want to convey about art. That's how it is. They don't saturate, they don't reach progress. One disappears, the other appears. So inside is cumulative, standing on the shoulders of giants, the famous phrase of Isaac Newton, which actually was put down on Robert Hooke, who was kind of dwarf-like, and he hated him. In fact, the only poem of Hooke that exists in the Royal Society, Newton lost. So in science, you build your argument, you put your references, you build in technology, the only reason to stand on the shoulders of an elder giant is to crush the elder giant. You want your technology to displace the previous one. You don't have much reverence for that. And it's a bad idea to stand close to anybody, because the worst thing that they can tell you is your work is derivative, that somehow you have to appear like a new shiny light in there. Okay? So physics discovers, for example, engineering invents, creates, and I think CS expands all three. But I mentioned in passing the clock world, and I want to put it in perspective, okay? Because since we're going to talk about the future, it's important to kind of give a sense on how the past was. And this is what, I'm not going to go through this, and you cannot read what is in there, but this is connected with the Clocks and Clouds, a notebook that I'm writing. And in here, I have all the revolutions. The poor chemists are not there. There was a chemistry revolution almost before Newton. These people got no credit. In fact, they had to battle all the people with alchemy, and everybody thought that they knew some chemistry because, after all, you're producing alloys and dyeing textiles. No one was throwing balls from inclined planes. So you have started with the power of the many, which is statistical mechanics, then the death of the absolute relativity, the dual nature of things, quantum. I put here game theory. Game theory is not a revolution in the sense that it didn't battle any previous point. It suddenly appeared out of the mind of all knowing, okay? And then after that, I have evolution, which chronologically I showed you before, the discrete nature of nature, the end of evolution, and then the dawn of the discrete, which is what you are guys part of, and everything that follows out of it. Okay. So the main reason that I put this in here is all of those things in there, they all were consequence of fixing a flaw in Newton's ideas. They all emanated from physics. Okay. And all the ones below, including, I would say, parts of the universe that you live in, because almost at the same time that one week were doing DNA replication, Paul Neumann was doing the same things with cellular automata and things. All of these originated outside physics, and they are all connected with life working. Okay? Very cloud-like there, more cloud-like in here. So the Newtonian thinking was deterministic, complete predictability, every effect had a clear identifiable cause. And this analytical thinking, as I mentioned, had amazing concepts. So it gave us the Enlightenment, the power of reason, the Industrial Revolution, and everything that follows. And the Industrial Revolution, which is the main subject of research of our colleague and Nobel Prize winner, Joel Mokyr, has done amazing things, okay? But I will mention briefly some of the consequences of the Newtonian viewpoint. For example, it altered the concept of God. You have to somehow fix it. If everything was determined by the initial conditions and the future was completely determined by the present, philosophy affected people like Kant, Rousseau, a whole bunch of things. Economics, the Adam Smith, the invisible hand, self-regulated markets, the power of the market to adapt itself, the invisible hand, politics and government. All the founding fathers were Newtonians. Deism was called the religion that they belong to. Checks and balances, very much sort of absent from the world now. That's an idea that came from Newtonian thinking. The Constitution of the US. The separation of powers comes from there, okay? By the way, the other thing is everything that you see, performance metrics, organization, the concept of a modern organization as a machine, all from Newtonian. And what this gave us, Newtonianism, the Enlightenment, the Industrial Revolution, was the idea that progress was cumulative. I don't know if you know this, but before the Renaissance, the idea of innovation and progress was not part of the human vocabulary. All the knowledge was resided with the ancients. Okay, the Industrial Revolution was that fused discovery, invention, and enterprise. Knowledge, production began to amplify each other, okay? So knowledge and organization becomes the engine of growth. And don't ask me how people were able to compute the GDP in the year 500 or 1000, but this is the GDP, and this is 2024. I do not know when the advent of computers came, but somewhere in here, okay? But this is basically the main topic of this book by Joel Mokyr, okay? Who, by the way, if you want to watch a really nice, understandable Nobel Prize lecture, go to the Nobel website and look at it. He's very, very pro-technology. Okay, so now I would say we are in the digital continuation of Enlightenment project, okay? We went from natural laws, Enlightenment, nature governed by universal laws. Industrial Revolution was these laws embedded in machines. Okay? And at that point, you could see how the machines work, okay? When digital comes into the picture, we kind of, you can see it, but many people cannot see it. The rules are encoded as algorithms. So we went from mechanizing energy to having algorithms that operationalize rules that can be executed, replicated, and the implications are very clear. So what is being extended is calculation. Okay? The speed and accuracy of human capacity, storage. Have to come look it in the book, coordination. There may be other ones, but those are the three that I can think of. And so we went from productivity of labor, being the rate controlling things, from productivity of organized information. So the Enlightenment gave us that knowledge builds cumulatively. Now, there is almost no cost to disseminate information. Okay? Moreover, you have persistent, by that I mean durable, knowledge repositories, and you can control distributed collaboration with these tools. So you have this loop gets intended, the discovery, application, no question discovery, through that gets amplified. Okay? So, and the rate of recombination of knowledge is exponential. Ideas having birth or sex with other ideas create more ideas and keeps going like that. So in the Newtonian model, you went from stability, predictability, control to a reality now that is continuous updating, interdependence, and the more partial visibility of things. People could understand how a steam engine works, even if you had no idea about anything of the laws of physics, you could see it. So the tension now is that our tools evolve faster and faster than our assumptions. So we went from systems that we can specify to systems that we must interact with. Okay? So, but out of this triumph, you can see some beginnings of problems. The rules explicit, process executable, systems scalable, that's all fine. But then you discover that not all processes can be fully specified, that not all systems are decomposable, even that not all outcomes are predictable when you put them together. So the key concept is what can be formalized, it can be automated, okay? But a lot of the world resists formalization. So we are going from systems that we can fully specify in, I don't know, 1950, 40, to systems that we can only engage with. So let me go to the clocks and clouds world, because this is what originated some of these ideas. And I'm not going to spend too much time on this, but in that book, I have this thing in which everything on the left is a consequence of Newtonian thinking. Okay? You don't design a nuclear site, some improvising what each part will go. There's a blueprint, everything gets put in the right location. And if you don't want the system to fail, you better back up the things, even double backup. All the things on the right are things that I would call complex, complicated and complex. Complex systems are systems in which the components could be pretty simple, if you can call a fish simple, but you can study a fish to death and never understand how fish forms schools. Or you can understand a neuron to death and never possibly understand how consciousness emerges. Ecology is complex. So that's all Newtonian thinking and complicated complex. So, and I mentioned in passing that Karl Popper in 1966 compared the regularity and precision of clocks with the unpredictable, not sudden, but amorphous nature of clouds. Clock problems are complicated. They can be broken down and analyzed piece by piece. Cloud problems are complex. These problems exhibit emergence. And so it's cloud thinking here, cloud thinking there, but a lot of things in here, I could have put a car in here. God knows planes. When you're endowing something with AI, the things are kind of blurring into each other. Okay? So we went from this to that world that is the one that we inhabit now. And so this is what I'm stretching myself. Okay? This is three things where CS meets the cloud world. Okay? I guess the first one, optimization as ideology. If I were saying these ideas in other parts of campus, it would be more controversial. Okay? Then I will talk about end-to-end science and then contingency. So optimization as ideology is we can only optimize what we can measure, and we measure only what we can formalize. And what we cannot measure and formalize somehow disappears from our field of view. You can go and optimize ahead, and you can optimize correctly the problem that you said that has to be optimized, but you're optimizing something that doesn't represent reality. Okay? Because what gets left is meaning, context, judgment, everything. So optimization as ideology is the following. Optimization answers the question, how do we get more or less of something that we want? But what it cannot do is question whether or not the objective function is the right one. So applied to clock problems, magnificent. Applied to cloud problems, finds the local maximum, call it that. Okay? The problem is that there's a prestige trap on this outside. Board of the authority of science and looks good even when applies to problems where it shouldn't apply. Okay? And that's the big problem of applying cloud thinking to cloud problems. So more than that, you optimize a system, and since you don't capture the whole thing, the system drifts between what you say and what the system does. The objective function stays fixed, the problem moves, and the gap widens. So, end-to-end automated science, no one is, there are a few people who are calling for this. And in fact, parts of the DOE Genesis project could be like this, but they're specified. We want to do this, okay? But there's no question that AI is affecting science big way. I don't know if you saw a paper at the University of Chicago, a sociologist, look at several disciplines. Computer science was not there because they're part of the ones doing this, but look at chemistry, biology, and this paper, John Evans, and two other guys, found that people in science, biology, chemistry, who use AI get more citations, probably faster in that ones. But when you look at systems macroscopically, the questions that are being looked at. So the idea of this end-to-end science is that AI will come up with questions, such as hypotheses, such as experiments. Humans or robots humans will become helpers. There will be papers produced, reviews generated, that kind of thing. And you could argue that this is just part of the natural evolution of science. This is inevitable, this is happening. And if you use the word evolution in a sort of metaphorical sense, it's fine. If you use, by the way, when I'm talking about AI, what's going on now with these large language models, just to clarify, okay? Science has evolved. I mean, not some didn't apply for funding, okay? There were no national efforts. There were not organizations that look at the integrity of science, nothing like that. So this could be the next step in the evolution of science. Except that this is not how evolution works. Darwinian evolution is not about increasing efficiency. In fact, it's very, very inefficient. You create a ton of possibilities in the past landscape, most of which are complete junk. One of them will adapt, And the point is, if you put everything through a machine, those things at the edges will disappear, and you will get more volume, but probably the more volume will be less real. I articulated this, the acceleration is real and transformative, but raises deeper questions like the ones that I mentioned now. So I would argue that science evolves as a system that depends on distributed variation and partial independence. Let me put it this way. I think the university, Northwestern, could benefit from having some AI tools with HR components in central. But if you want to optimize what you guys do here, that's a bad idea, because you want to have lots of people doing things, going their own way. That's how science is. So I put these ideas in a more elegant way in this progression without progress. Is the editorial in Science magazine is coming tomorrow. Okay. Contingency is an idea coming from philosophy, and it's probably the deepest break from Newtonianism. Is that at any given point in time, as opposed to Laplace's demon, the future is not merely unknown, it's completely open. Multiple futures are possible at any given moment, and some possibilities don't exist because they wait for some human action to take place. A contingency, not error or noise, is part of reality itself. Okay, I have been influenced on this by my colleague Sol Morton, which is Russian literature, and we are doing things together. And one of the prime examples of contingency that he always brings is Tolstoy. And he has this phrase: if we concede that human life can be governed entirely by reason, the possibility of life is destroyed. But he injected these ideas constantly. And in War and Peace, he contrasts someone who had a plan completely, strategic plans, they last a year if you're lucky. So what really carries the day is the possibility of being adaptable. Okay. So, but the point is, AI is amazingly good in reducing uncertainty if you deploy it in this way, okay, within a known framework. The problem is that in some cases, you don't even know what framework you're in. But business case studies, why code that failed, Polaroid or Blockbuster, they all look really clear in retrospect. When you give all the background materials to people, and more or less they say, well, no, I would have done it this way. Because at any given point in time, you have this backshadowing in which the things look inevitable, but that's not how life is, okay? So you can find causal change that make history be completely determined, okay? And that's a lot of how history gets taught, okay? But the future is really, for us, open. So a few ideas about putting this together. So CS is uniquely positioned to operate within the productive tension that exists in the world now, okay? CX sits at the confluence of things that are clock thinking, cloud thinking, both, okay? If you want to produce new things, you have to recognize that require different modes of thinking. Breakthroughs, formal rigor will be fine. Break with require navigation and imagination, in my view, okay? I think at that moment we are doing one without thinking, in my view. As I said, I am going to 50,000 feet here, trying to look at things from high altitude. I must mention that the most interesting philosophical discussions I with any department were with people here, okay? Ever. But the idea now is that to operate in this world, you need maps and you need compasses, okay? in some sense, a lot of engineering education is equipping people with maps. Maps give you tools that they are great when the territory is stable. Okay. A manifestation of a map will be a plan, a strategic plan if you want. Clouds, tools are less precise but indispensable, like a compass when the territory is unmapped or unchanged. Or, to give one example, if you are dropped in the middle of the Amazon and you cannot see more than 5 feet in front of you, what would you rather have? A map that will tell you the elevation of mountains, let's say 3 or 4 kilometers away, rivers a kilometer away, or a compass that tells you which direction you should move consistently rather than moving itself. So when the future in front is completely cloudy, a map is one. So this goes into issues of leadership. Leaders using maps and compasses using. So it's not an argument against rigor, playing the compass angle. Is for a different kind of rigor. Is the rigor of being robust against wrong assumptions, and what I would call model humility. Okay, that the model can change because everything around changes. So, as I said at the beginning, you have built the landscape that we all operate under. Okay, has modified the behavior of billions of people, changed the way that we shop, communicate, and in this landscape, one thing that I like to think about is two kind of species of. Not everybody fits in this species, or few. Okay, gamers. By gamers, I don't mean people who play games like in consoles or in arenas. I had recently a podcast with a fellow named C.T. Newman, an interesting guy. It was an experiment that someone puts 2 people and they say go. And when he told me who he was, I thought this would be not good. He's a philosopher, but then I discovered that before going into philosophy, he was a food critic for the LA Times. Well, that kind of makes it different. He wrote a book about games. So he sees the whole world as games, and now he has another one in his course. So the landscape, this landscape that we have, it produces some people really great in playing games in the landscape and have even metrics to quantify how well they do. It happens that some of these best adapted people are probably the most useless people in society. I'm talking about influencers. Okay? The question is, if you want to do good, you become a game designer, but you have to create games that how implicitly incite people to play, but to do some good. Okay, and that's I'm not going to get into that, but this an interesting angle to think about these things. So you are not really solving problems; you are designing environments. You decide what people see, what people choose, what people become, and I don't know how many of you think in this way, but more than solving problems, you are designing worlds. Okay, you are builders of reality. So I think you go from solving problems to designing worlds, from optimization to navigation, from prediction to resilience, formalization to judgment, from maps to compasses. And CS now is shaping. That's why I put it in the title, the architecture of reality. So, as I said, I will mention a few words, and I did. I wouldn't say this is very stretching things. The vocabulary that we need. No, this is part of the vocabulary that could be useful in talking about these things. But these were some of the the words that I brought in here. Clocks, clouds, maps, compasses, breakthroughs, breakways. And I don't know if you want this to put it in the website, CS as a builder of your thinking, but it's very true. Okay. So the issue now is that you have power without precedent because you have scale, speed, and reach. That's it without precedent. But it's also responsibility without precedent. Okay? Because there are no boundaries, there are no external referees, and there's no historical template. This is really good area for, but this you have to connect with people in sociology or philosophy, whatever. So what I want to leave you with, and we have time for lots of questions, is that the world ahead will be built by those who can think in both clocks and clouds, and CS is one